So here is the Jupyter Hub. You can have the link of it on the Padlet, and you will have all the information about the e-learning material from the Padlet. All the notebooks that we're interested in today, they are stored in the folder Shared Notebooks here. So if you go in this folder, you can see that you have several subfolders. They all refer to some previous workshops we've had. So you have the ones for the global ocean, so about the African, American, and Asian regions. You also have the previous regional workshops we've had, so about the Arctic, the Baltic, and the Mediterranean Sea from 2020. And you have the notebooks we're interested in, so for the Baltic Sea 2022. The first thing to do when you reach the Jupyter Hub is to download to copy the folders of the workshop you want in your home directory, because in the Shared Notebooks folder here, you don't have any rights to run or to write, so you won't be able to work in this folder. So to copy the directories, you open a terminal, clicking here. And then you write the following line. You copy the Shared Notebooks Baltic, and you add the dot in the end to specify that you want to copy it in your home directory. And once you've done it, you will see that the folder Training Baltic 2022 will appear in your home directory. In this folder, you will see that you have two subfolders, one about the beginner exercise and one about the intermediate level exercise. As I've said before, in this session today, we're going to have the whole demonstration of the beginner exercise, and we're also going to see briefly the second one, but the second one has been recorded on a video, very precise video, and you can find it here in the Padlet. In the e-learning material, you have the video of the presentation of the second exercise. So let's begin with our first exercise. So you have to you have to open the Jupyter notebook, which is entitled Baltic Beginner Overview. If you're not familiar with Jupyter notebooks, this is how it looks. You have text, and you also have code, Python code. If you want to run a cell, you can click on the arrow on the top here, or you can use the keyboard shortcut Shift and Enter. And if for any reason the notebook does not work anymore, you can restart it and clicking on the arrow here. So as I have said before, this is the first notebook of the workshop dedicated to beginners. In this notebook, we're going to see how to access the Copernicus Marine Service products, how to manipulate them in Python, and how to create useful working figures. And as an example of how to do this, we're going to follow an exercise about in which we will analyze the Baltic Sea temperature in several different ways. So let's begin the exercise. We're going to work with 3 Copernicus Marine data sets, which refer to a model product, a satellite observation product, and an in-situ observation product. All these products have been presented on the session yesterday, and if you're interested in these products, again, in the Padlet, you can find the presentations of yesterday. The model product we're going to use is the Baltic Sea Physics Analysis and Forecast model. If you click on the link here, you will access the product page in the Copernicus Marine Catalog. On this page, you can find all the information on the product, so the geographical coverage, the temporal resolution, the spatial resolution as well, all the variables that are computed in this product. And you can also find the data access, which I'm going to present you later. So this is the Baltic Sea physics analysis and forecast. You can see that you have several temporal resolutions. What we are going to study here is the monthly means. So we're going to have one value per month, and we're going to study the variables sea water potential temperature. The second dataset we will use is from the European Ocean Sea Surface Temperature L4 analysis. So these are satellite observation. Again, if you click on the link here, you will open the product webpage, and you will find again all the information about how the product has been constructed and the variables we're interested in, so the sea surface temperature. The last product we are going to use is a temperature profile from a glider instrument. So this is an in-situ data set. In this notebook, we won't show you how to access the in-situ data sets, but in the previous one, so in the Baltic Sea training from 2020, several notebooks had been developed to show you how to access the in-situ data. In the Access in situ here, you have some of the notebooks that enable to download this file. So I'm going to show you very briefly how it works, how they work. So the in situ data set, the in situ products are all gathered in a huge database. And to download them, you have to apply some filters to subset this huge database. And you can apply many filters depending on the time range you're interested in, the geographical area you want, the type of instrument you're interested in, or the parameters. So these are examples of the filters you can apply to your database. And if you go through these notebooks, they are very easy to follow and very well explained. And then you'll be able to download any in situ product you want. So in the following sections, I'm going to present you several ways to access the products, so the model and satellite observation products. But if you download if you're using this folder, you will see that all the data that we're going to work with, they have already been downloaded and they are stored in the data folder here. So to follow this exercise, you don't have to download anything. But if you want to study another region or another time period, then you can follow the following sections to download some other products. So the solution number one to download the products, which in my opinion is the easiest way, it's very user-friendly, is to do it from the catalog. So here you have a link to a tutorial that shows you how to use the catalog to download the products. If we go back to the Baltic Sea, for example, to the model product, you can see here the data access. As I've said, we're going to work with monthly means. If you click here on the subs section, you have to enter your credentials. And then you're going to have several filters to apply to the data set. So you can select the geographical area you are interested in. So this is the Baltic Sea. You can select some time range. so the beginning, the start and end dates you want. You can also access several depths and download the variables you want. So here, for example, we are going to work with the potential temperature. Then you can click on the download, and the file, which is going to be an etcdf file, is going to be directly downloaded on your computer. So this was the first solution to download the products. The second one is from the Motu client. The Motu client can be very useful because it enables to download the products directly within Python and within the Jupyter Hub. The first thing to do is to run this cell, but yeah, that's it. And then you're going to create
لا ما هو بيجيب لي متأخر وانا كده كده بفطر
you're
متأخر.
going to, sorry for this, you're going to have to use a command line just like this one. So what you can see is that you connect to the Motu client, then you tell the product you want to use, the sub data set you want to use, the min and max latitude, longitude, dates, and depths, also the variables you want to have. You specify the output directory, the output file name. You have to set your username and passwords. So this line may be very complicated, but hopefully, if we go back to the catalog here, you can click on the download option, then view script, and all the command line, depending on the filters you have applied from the catalog, the command line is generated automatically. So this is very useful, and you don't have to learn by heart how to do this. So if you run this cell without forgetting to set your username and password, the file is going to be downloaded just like this. And the product is going to be downloaded in your directory. This is the product. So this was for solution number 2. Now we're going to the third one with the FTP. So the FTP is a little bit more complicated than the other solution, I think. You cannot apply any filter, but you will download the whole file. So either one whole day or one whole month or one whole year. If we go to the data access of a product here, you will find the link to the FTP. So if you click here, you can copy the link here. And then within Python, you will import the FTP library, set your username, password, and then you connect to the FTP server. Then you change directory to access the product you're interested in. And then you have to list the files, the directories that are in the product FTP page. And then you change directories until you reach the netcdf file you're interested in. And then finally, you can download it. I've been quick on this section, but if you read the text, it's very well explained, and you shouldn't have any problem to use the FTP. So this was the solution number 3. And now we're going to see the last one, which is the OpenDAP service. In the 3 previous methods, we ended up downloading the files. So we had the netcdf files physically in either our computer or the Jupyter Hub. But the last solution enables to, well, not download anything, but just to stream the product you want to use. So this may be very useful, especially if you don't want to download very huge files, because the netcdf files can be sometimes very heavy. So what you need to do is first to run this line to set up the OpenDAP. Again, you enter your credentials. And then if we go back to the data access of a product, you have the link to the opened app. So if you click on the API here, you will find the link to the opened app, to the product you want. And I'm going to show you very soon, just after, that it's very easy to use the products with opened app, just as easy as if it was downloaded. So now that we know more about the products we're going to use and how we can access them, we can begin to explore the products with Python. As I have said before, all the products we want, they are in the data folder here. They all have been downloaded before. And so the Jupyter notebooks needs to be initialized just like any other Python code. So we're going to import the libraries we want. We're going to work with 4 libraries. So the first one is Numpy, which is a very basic Python library for scientific computing. We're going to work with Xarray. Xarray is also, it's the library that we use in Python to manipulate netcdf files. Very user-friendly as well. We're going to work with matplotlib, which is the library to produce figures, and Cartopy, which is used to plot maps and geospatial data analysis. You can find the links to the web pages of the libraries here, and these libraries are very commonly used. So if you need anything, someone will probably have done it before, and you can find plenty of documentation either on the web page or on the library's documentations or on the internet. You should have all the information you need. So first, we import the libraries. This is what this cell does. And then we're going to load the files. To do so, we use the xarray.opendataset function. And so, as I have presented before, we have 3 datasets we're going to work with. So the model, the satellite, and the in situ dataset. The first thing to do is to define the paths to the netcdf files. So these are the paths for the 3 products, and then we open them with the functions open dataset. So in the end, we have 3 Python variables that all refer to one of the products, so the model, the satellite, and the glider in situ instrument. So if we run this cell, it doesn't display anything because we don't ask Python to display anything, but there's no problem, and we will see later that we have loaded the products. You can do the same with the opened app. So the last solution I presented to access the Copernicus Marine products. So just like you had put the path to the model in the open dataset function before, you just have to put the link of the opened app product you have got before, and it will work just the same. It works just the same. To display the content of the file, you just have to put the name of your variable into a Python code cell, and if you run it, you will see what the file, the dataset contains. So the files we have downloaded, they are netcdf files. They are very commonly used for scientific studies. The netcdf files, they contain several coordinates. So usually it's latitude, longitude, depth, and time. So this is what if we take the model variable, for example, This is what the coordinates are. You can also access the variables. So if you click here on the show hide attributes, you will see the information about your variable. So here, for example, you can see that this variable refers to the sea ice cover. And if we have a look at the second one, you can see that it's the potential temperature and that its units are Celsius degrees. We can also see that here we have 7 time dates included in the model dataset and 30 depths. So that's it for the model. I'm going to show you that the OpenDAP service works just as fine as if you had downloaded the file. So remember that we had stored the OpenDAP dataset into the mod OpenDAP Python variable. So if we run this cell, you will see that it displays the same kind of information, except that the dataset we had downloaded had been subset before, whereas with the OpenDAP, you access the whole product. So you have all the variables, all the depths, and all the time dates that are computed in the model. For the rest of the exercise, I'm going to work with the files that have been downloaded, but I can assure you that it will work the same with the OpenDAP variables. So you have seen that several variables were included in the dataset. You can see here that mod is a dataset variable, which means that it contains several variables. So you have the sea ice coverage and the potential temperature. If you want to access only one of these variables, you have to put the name of your variable. So here the temperature is named theta. And if you put this, if you put it this way, you will access a data array. So you no longer have several variables, you only have the temperature. And again, if you want to display the content of your data array, you only have to put the name of your variable and it will be displayed this way. So this is a data array, which means that we still have the information on the coordinates. So if we want to access the time dates, if you click here on the show hide data rep, you have all the dates that are computed. If you only want to use the data as an array, so with no information on the coordinates, you can use the .data function, and then you will see, so for the sea ice, for example, that you only have a row array, so with only the values of the sea ice. So now that we know about the netcdf files and how to explore them with Python, we're going to start studying the Baltic Sea temperature. The first thing that we are going to do is to select some part of the model. Let's say, for example, that we want to plot the temperature for November 2021. If we have a look at the time that are computed in the model product, you can see that the dates go from August 2021 to January 2022. And so if we want to select only one date, we're going to have to use the .cell or .icell methods from the Xarray library. So if you know the exact date, so the date that is written in the model, you just have to put model.cell time equals and then the date you want. And if you run this cell, you will see that the time is indeed, you now only have one time in your data set, and that is November 2021. However, if you try to change the date, like let's say the 15th, because you can see here it's the 16th, if we put the wrong date, you will see that there is an error and you won't be able to use this dataset because you have no time coordinate. We go back to the 16th. If you don't know the exact date, you can use the method nearest. So this is one of the options. You can also select, some linear interpolation. But if you take nearest, for example, you will select the nearest date to the one you have specified here. And you can see in the time here that you have the date we wanted, November 2021. If you know the index of the date you want, for example, here we want November 2021. So this is the index 0, 1, 2, and 3. So if you select with the function icell time, you take the third element, you will see as well that you have selected the right time, the time you wanted. And finally, the last thing you may be interested in is how to select a range of dates. So if we want the dates from August to December, for example, you have to use the slice method. And if you do so, you can see we now have 5 date times instead of 7. And you're going to be able to work with this. So we can now plot our first map. We're going to plot the sea surface temperature on November 2021. For all the figures that I'm going to present you, I'm going to first show you the result and then show you how the figure has been constructed. So on the figure here, you have so this is the Baltic Sea. The color refers to the temperature in Celsius degrees. You have the landmass here. You have a black line that refers to the coastline, and you have the title. So how did we build this first map? The first thing to do was to subset the data set. So we want the surface temperature. So we select the first, the nearest depth to the surface. This is what we do first. Here we select the temperature. And then we select the time, so November 2021. Then we define the characteristics of the plot. So we define the size of the figure here. We select the projection. We add the coastline, so the black line here. We add the grid lines, so the latitude and longitude lines. We remove the labels on the right and on the top. You can see here you have no latitude and longitude labels. And you add the landmass here, and you set the extent. So these are the coordinates of the box we are studying. And if you want to zoom on a specific region, you can change these coordinates. Then you can finally plot the temperature. To do so, we use the pcolor function. If you click on the link here, you will access the documentation page of this function. It works with the first parameter you set is the longitude, so the parameters in the x-axis, then the latitude, and then you put the temperature, so the variable we have set just before. You can specify the min and max values of the color map. So here you can see it goes from 3 to 12, and you can choose a color map. So here I've chosen from blue to yellow. You then add the title and the color bar. You add the units here, Celsius degrees, and finally you can save it in the out folder. If you have a look, top map, you can see that your figure has been saved. So this was for the first map. If you want to be more familiar with this first script, you can try to change the extent so the box you are studying, try to make a zoom. You can try to change the min and max values. You can try to change the color maps. There are plenty of nice color maps to use if you have a look on the internet. And you can also select another date if you want. So this was the first map from the model product. What we are going to do now is to plot the time series. So we're going to set the location of one point and to see how the surface temperature has evolved at this location for a month. So we're going to work now with the satellite observation. So if you put the name of the variable set, we can see that its coordinates are time, latitude, and longitude. So we don't have the depth because it's only the surface temperature. And if we have a look at the variable that refers to the sea surface temperature, if you have a look at the attributes, you can see that its units are Kelvin degrees. You may not be familiar with Kelvin degrees. It may be more useful for you to work with Celsius degrees. And it's very easy in Python and with Xarray to manipulate the netcdf files, the data sets. So if you want to, so you can apply any operation you want, addition, subtraction, multiplication, etc., to your data set. And if you want to convert the Kelvins into Celsius degrees, you just have to subtract 273 degrees. And if you have a look at this, you can see that the units are now, well, the temperature is now in Celsius degrees. So now let's start our time series. So we're going to define the longitude and latitude we want to study. So I've set some coordinates, but you can choose any other one you want. We're going to see the evolution of the temperature from, well, in November, so from the 1st to the 30th. We select the satellite observation dataset with the coordinates and dates we have set. So we select the longitude, latitude with the nearest method. And for the time selection, we take the slice, so from date min to date max. We convert the dataset we have created from Kelvin to Celsius degrees. And if we run this cell, you will see that you have all the information you need. So all the time dates that are represented, all the temperature values, and the latitude and longitude we have set. Again, I'm going to show you the result of the time series we have plotted before showing you how it worked. So you can see on the bottom, on the x-axis, we have the time. Here we have the temperature. We have the line that describes the evolution of the sea surface temperature. On the right, we have the location of the point we are studying. On the left, we have the location we have set. And you have the title, sea surface temperature. Well, how did we create this figure? Again, we define the characteristic of the plot, so the size. We add the axis, we add the grid, we set the title, the subtitle on the left. We use this line for the x-axis to look nice. And then we use the function plot. So on the x-axis, we have the time, and then we have the temperature that we have defined above. Then these lines are used to create the minimap. We use the function scatter, longitude, latitude to plot this point and to display the location of the point we're studying. And so that's it. So a little analysis we can make on this time series is that the temperature decreases in November because obviously winter is coming, and so the temperature decreases. A small exercise you can try to do with the script is to change the location and dates you're studying, and see if in August the trend was the same as in November, for example. So that was for the satellite observation and some time series. We are now going to study the glider, so the in situ instrument. And we're going to plot a vertical temperature profile, so see how the temperature evolves in the deeper sea layers. So let's have a look at how the glider dataset is constructed, just to make sure. A glider is an underwater vehicle that measures some ocean parameters. So for each time date, we have a set of measurements for several depths. So here are the coordinates that are computed in this file. You have time, latitude and longitude. And if you have a look at the dimensions, you also have the depth and the position. You have plenty of variable. Sorry. You have plenty of variables: the pressure, the temperature, the salinity, etc. What we're going to work with is the temperature, obviously. And so from all these measurements, we're going to select two set of measurements. So we set the indexes of the measurements to consider. So here I've chosen to select the first one and the index number 9. What we do next is that we get the dates of these measurements. So we select the time that refer to these indexes. We get the longitude and latitude of these measurements, so for the 2 points. And finally, we get the temperature measured that the glider has measured. So we have several variables that we have set. And if we have a look at this second variable, you can see that you have all the values of the temperature, you have the time at which these measures have been made, etc. So again, I show you the result of the script we're going to run. Again, on the top, you have the location of the 2 points we have selected. You can see they are very near. Here on the top left corner, you have the dates at which these measurements have been made. So 1st of November and 7th of November. Here on the y-axis, we have the depth, and on the x-axis, we have the temperature. And the lines refer to the measurements made by the glider at these 2 dates. So how did we create this? It's very easy again. We set the characteristics of the plot. So the only difference from the previous plot is that we add this line to revert the y-axis, so that we have the 0 that refers to the surface on the top. And then we use the plot function. On the x-axis, we have the temperature, and on the y-axis, we have the depth. We add the labels, which refer to the legend on the top left corner. Again, we add the minimap, and in the end, we plot the legend and specify we want it in the upper left corner. So this is this is the result. What you can see is that the temperature for the 2 measurements is quite still until 30 meters, and then the temperature decreases, and then it increases again. This is what we can say about these temperature profiles. If you want to manipulate this file, this script, you can select some other indexes and see if you see the same profiles, for example. I'm going to be quick because I think I'm running quite out of time. In this section, we're going to plot the vertical slice. So the aim of this figure is to see how the temperature has evolved along a line and taking into account the depth. So here is the figure we are plotting. We have defined the line here, so along this this longitude. And the result is this one. So you can see this is the shape of the background of the floor, the sea floor. The colors refer to the temperature. This is the depth and this is the latitude. And we have also selected the date, so from August 2021. What you can see is that, as we have seen in the previous vertical profile, the temperature at the surface is warmer than in the sea bottom. And you can also see that in the south, the temperature is warmer than in the north. This is a basic analysis you can make from this plot. The last section of this notebook will teach you how to create an animation, because here we have selected only 1 month, so August 2021. What you can do, so to plot this map, if you have a look here, we selected the index 0 of the model dataset. What we can try to make is to create a loop on all the date times that are included in the MUD dataset. So this is what we do now. All the figures we create, we download them, we save them into the out animation folder, and then this last cell will compute all these figures and save them as a GIF. And if we run this, it should work. Yes. And you can see how the temperature has evolved, so from August to January. So that's it for the first notebook. I hope I haven't been too fast, and I hope you enjoyed it. So we have seen the fundamentals of Python to access the Copernicus Marine Service products. We have seen how to download and how to stream them with the OpenDAP service. We have seen how to manipulate the files, so how to subset them, how to select the variables we want. We have learned how NetCDF files were constructed, so with the dimensions, the variables, etc. And we have learned how to plot maps, time series, vertical profiles, and vertical slices. So you now, once you're familiar with these notebooks and all the methods we have presented, you can reuse all the scripts we have developed for you and apply them to your needs.